All right, for you following at home, we're going to spend a couple of days on exponent rules, or as I like to say, exponents rule. This is one of my favorite units. Um, if you're in school with me this week, we're going to take these formal rules, these formal notes during class. So please go do the Desmos activity. If you're at home, we've got notes and we've got a Desmos activity. Do them over the course of the week, whichever order you would like to do them in. So we're going into a new unit now, just about exponents and exponential functions. We're going to keep it brief this year. Usually I do a deep dive into these. We just don't have time this year, so we'll keep it simple. Couple things about exponents, just some vocab before we get started. We write these exponents as a to the b. That b we call, a couple things, we call it the exponent. Sometimes we also call it the power. And a, that big number, is called the base. So we have a base raised to a power or raised to an exponent. That means that we're taking that base and we're multiplying it by itself b times. So if we had 2 to the third power, that would mean 2 times 2 times 2. We can write that as 2 to the third, or we could write that as 8. If the numbers are small enough, we can simplify. But we use these exponents for big and small numbers. They're sometimes more convenient to write that way. Okay, so base, exponent, power. Our first rule is going to look at what happens when something is raised to the first power. Now, some of these rules are going to seem really obvious. I just want to write them down formally. 3 to the first means 3 times itself once, which is 3. 5 to the first would be 5. 99 to the first would be 99. We're going to write these out in 3 different ways. We're going to do a couple examples. We're going to write algebraically what this means. A to the first is A. And then we're also going to write down the rule in words. So for each one of these, we're going to repeat these. We should know the rule in words. We repeat them in our head and they become solidified for us. But we also want to write the algebraic rule. So I'm going to type out the rule for anything to the first power. And our rule is, and again, pretty simple one here, anything to the first power is equal to itself. Our second rule deals with kind of the definition of our exponents here. So 3 to the fourth would mean 3 times 3 times 3 times 3. And again, if the numbers are small enough, we can write that out. I believe that's 243. 5 to the 6 would be 5 times itself 6 times. Now, I don't know what 5 to the 6 is off the top of my head. If you want to do that out on a calculator, that's great. But we can express 5 to the 6 as 5 to the 6. Negative 1 to the 13th. Here's an important one. That would be negative 1 times itself 13 times. An important thing to think about here, when a negative is raised to a power, does the answer end up negative or positive? I want you to think that through for a minute. And this would be negative 1 to the 13th. Negative 1 times itself 13 times. And I could write that out expanded. Negative 1 times negative 1 times negative 1. This is called expanded notation. Negative 1, and keep doing that 13 times. Would the answer end up being positive 1 or negative 1? Well, our answer would be negative 1, and I want you to see if you can come up with the reason for that for me. If we have a fraction raised to an exponent, that just means that fraction times itself, however many times. 2/5 to the third would be 2/5 times 2/5. 2/5. Now we remember how we multiply fractions. We just multiply straight across. That's the same as saying 2 to the third over 5 to the third. Also known as 2 to the third is 8. 5 to the third is 125. So fractions raised to exponents, no big deal. Again, our formal definition here, what we're going to write algebraically, is what we wrote on the last slide. A to the m means a times a times a, dot, 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 times a. I'm good at writing those squiggly brackets upside down even. We're going to do that m times. And I'll write out the rule. You should be taking these notes along with me. I'm going to type out the rule. It's a little quicker for me to do it that way. And again, that formal definition, a to the m tells us to multiply a by itself m times. Now again, these are introductory rules. We're going to get to the more complicated ones coming up. But we need to have that foundation, that basis, the vocabulary to build on in order to get the rest of these rules. All right, we have 2 really important power rules here. We want to think about what this means. I'm going to write these in expanded notation so that you can kind of see where the rule comes from. We have 3 to the 5th times 3 to the 3rd. Now, really, really important to note that in these examples, the bases are the same. 3 and 3, 5 and 5, 10 and 10, A and A. These rules don't hold if those bases are not the same. Okay, so these are rules for when the bases are the same. So 3 to the 5th would mean 3 times 3 times 3 times 3 times 3. That would be multiplied by 3 to the 3rd, 3 times 3 times 3. Now, how many 3's do I get when I multiply those all out? Let's see, I have 1, 2, 3, 4, 5, 6, 7, 8. That's the same as 3 to the 8th. 5 to the 2nd would be 5 times 5, multiplied by 5 to the 4th, 5, 5, 5, 5, 5. Altogether, I have 5 to the 6th as my simplified exponent. Can you see where those numbers are coming from? 10 to the 4th would mean 10 times 10 times 10 times 10 times 10 to the 6th, 10, 10, 10, 10, 10, 10. Altogether, I have 10 to the 10th. And we can see where that final answer number comes from. If we write this in expanded notation, we can see what our rule is turning out to be. We get the final exponent, the 8, the 6, the 10, by adding the exponents that belong to those bases. And again, the base has to be the same. Our rule here, algebraically, a to the m times a to the n is equal to a to the m plus n. A to the m plus n. So our rule is, algebraically, we add those exponents. Our rule in words is going to be, we're going to write powers times powers, we add the exponents. Now I want you to keep saying that in your mind. We're going to shout it out all year long. I can still hear my Algebra 1 teacher having us yell this out at her when I learned the rules. Powers times powers, we add. Powers times powers, we add those exponents. Powers times powers, we add the exponents. Okay, so we've got that one first power rule about multiplication. The second rule is similar, but now we've got a power raised to another power. So again, I'm going to write these in expanded notation and let's see what happens. I may not do all of them because that 10 to the 4th to the 5th will get very long. So let's see, we have 5 to the 3rd to the 2nd. Well, that means 5 to the 3rd, which is 5 times 5 times 5, times itself twice. So our base is 5 to the 3rd. We multiply that by itself twice. How many 5's do we have there? We have 6. That's 5 to the 6th. 2 to the 4th, 2, 2, 2, 2, raised to the 3rd means 2 to the 4th times itself 3 times 2, 2, 2, 2. How many 2's do we have there altogether? 4, 8, we have 12. That's the same as 2 to the 12th power. Can you see where those exponents are coming from? Can you see where the 12 comes from based on these numbers? Can you see where the 6 comes from based on those numbers? What's your guess on 10 to the 4th to the 5th? 10 to the 4th would be 10 4 times, then to the 5th would mean multiply that by itself 5 times. How many 10's do I end up with at the end? Well, I've got 4 of them, then 4 of them, then 4 of them, 4 of them, 4 of them. I end up with 10 to the 20th. Our rule here, we can see where that's coming from, right? The exponent, the final exponent, comes from the product of the two exponents we started with. So if we think about how we're going to formally write a to the m to the n, that would be a to the mn, the product of m and n. Powers times powers, from the previous column, powers times powers, we add the exponents. This rule is powers raised to powers, we multiply the exponent. Powers times powers, we add the exponents. Powers raised to powers, we multiply the exponents. So look at the structure of those two different situations. In one, we have two separate things being multiplied together. Here we've got the same thing raised to another power. So powers times powers, we add those exponents. Powers raised to powers, we multiply the exponents. This is going to be the end of video 1. We're going to have more to come on the other rules.